All right, let's just dive right in. We're going to break down a cyber battle that takes place on February 12th, 2026. Now, yeah, this is a hypothetical scenario, but the tech and the tactics, they're based on stuff that's happening right now, giving us a pretty scary peek at what the future of cyber warfare could look like.
So, it all kicks off with this single alert from a defense system they call AegisNet. The time is 14:58 GMT. And this isn't just your average breach. Nope, this is a signal that a brand new apex predator has just been unleashed in the digital world.
And that really is the central question of this whole thing, isn't it? Because we're not talking about some static piece of code that you can just catch, analyze, and block. We're dealing with something that learns, something that adapts, something that evolves in real time.
The defenders are calling it AI native malware. And notice the word choice there, ecosystem. It's not just one program. It's a whole system that uses public generative AI to constantly rewrite its own DNA, making it a complete shapeshifter that traditional security signatures, well, they just can't see it. It's invisible.
So here's the basic loop, what they've dubbed the Gemini vector. Once the malware gets on a system, it just calls out to a public AI, like Gemini, and basically says, hey, make me a new version of myself. The AI spits back some modified code, and boom, the malware has a brand new disguise to slip past security. And get this, it does this every single hour.
Now, this is where it gets really mind-bending. With old-school malware, you're hunting for a file, a piece of static code. You find its fingerprint, its signature, and you can block it. Easy enough, but with this AI native stuff, you're not fighting a file anymore, you're fighting an idea, a prompt. The malware's body is always changing, but its soul, that initial command, stays the same. How do you fight that?
And the attack was just incredibly sophisticated. This malware, Prompt Flux, didn't just hit the software. Oh no, it went deeper. It burrowed its way right into the hardware's root of trust, meaning you could wipe the whole operating system and it would still be there. It was paired with a rootkit called Overstep. Think of it as a cloaking device that made it totally invisible. And to top it all off, the attackers were literally intercepting the satellite internet signal from orbit to push their malicious data. So the whole battle just unfolds at machine speed. 14:58, they spot the breach. By 15:30, as the defenders are scrambling to shut things down, the attacker's system is already one step ahead, automatically registering 14 new domains in just 15 minutes to keep the attack going. The hunt for this digital ghost goes from software right down to the silicon. And here's a look at that new infrastructure, just spun up on the fly. You can see it's a whole network, domains for every part of the attack. Backup, command and control, the C2, payload delivery, even the AI's logic stores. It's a game of whack-a-mole. Defenders shut down one path, and the AI instantly creates a dozen more. So how in the world do you find a rootkit like Overstep when it's designed to be completely invisible? Well, you stop looking for the software, and you start looking for its physical footprint. By analyzing the power draw on the hardware, the defenders found this tiny, almost imperceptible 0.3 milliwatt power spike on the SSD. That was it. That was the ghost in the machine. And this discovery leads to the fundamental million-dollar question. If your enemy can literally think and rewrite itself faster than you can react, your entire defensive playbook is useless. You can't outcompute an AI that can change the rules of the game every single hour. And this quote, this just perfectly illustrates the massive shift in thinking they needed. The answer from AegisNet isn't to build a faster computer or a smarter algorithm, it's to stop playing the AI's game entirely. It's time to move beyond digital logic and into something else. The first countermove is just brilliant. It's called counter-poisoning. So instead of trying to block the malware's calls to the AI, the defenders intercepted them, and they injected what they called hallucination seeds. Basically, just subtle corrupted data designed to confuse the heck out of the AI. And the result was absolutely catastrophic for the attackers. The AI, after being fed all this poisoned data, started generating code that was, and I love this phrase, semantically suicidal. The malware literally began encrypting its own command and control servers. The defenders tricked it into destroying itself from the inside out. Just beautiful. So what about the long game, the permanent solution? It's codenamed Axiom I, and it's a defense system rooted in biology. Instead of creating security keys from predictable math, it generates them from the totally unpredictable quantum-level behavior of proteins. The result? Chemical keys that are purely digital AI it can't compute them. It can't even comprehend them.
Okay, so what about the immediate hands-on cleanup? They called it the cold iron protocol.
And this wasn't just running an antivirus scan. No way. This was a deep, physical process. First, lock down the network. Second, manually block all the attacker's known IPs. And third, a deep hardware purification that involved physically removing a screw on the device to rewrite its core firmware, and then using a special command to wipe the hidden memory on the SSD where that ghost was hiding.
And this has to be my favorite detail in this whole thing. In this super high-tech war, the final confirmation that the malware is still kicking comes from an analog signal. When the hidden malware tries to call a blocked server, the Wi-Fi chip actually makes an audible, high-pitched 600 Hz chirp. You can literally hear the ghost trying to phone home. How wild is that?
This quote from Velma Hawthorne, the lead defender, just perfectly captures the new philosophy. Don't try to build a stronger shield to block the AI's sword. Instead, become a fundamental force of nature, like the very air itself, that makes the sword rust and fall apart on its own. You change the environment, and the weapon becomes useless.
And that really brings us to the big takeaway here. This whole incident suggests that to fight a thinking machine, you need more than just a smarter machine. It points to a future where our digital defenses have to become less like rigid, predictable fortresses and more like living, breathing, unpredictable systems. So as warfare becomes intelligent, maybe our defenses have to become alive.